Hi math students, today we're going to be learning about the interior angles of a polygon, and by the end of this lesson you should be able to find the missing angles in polygons. Now, a key fact that you need to know to be able to progress in this lesson is that the sum of angles in a triangle add up to 180 degrees. So what we have here is a triangle, and angle A plus angle B plus angle C will be equal to 180 degrees. Key fact that we need to know. Now over here what we have is an equilateral triangle because all the length of sides are the same, and that's indicated by the lines that we see over here. So if we have lines like these, that will indicate that the length of sides are the same. Therefore, the angles will also be the same. So this angle here and this angle here and this angle here will all be the same. So knowing that the sum of angles is equal to 180, what we would do in this case is 180 divided by 3, that will give us 60 degrees. So each angle in an equilateral triangle is going to be 60 degrees. Now, another example would be an isosceles triangle. So with an isosceles triangle, only two length of sides are the same. And again, that's indicated by the lines that we have over here. So if we know this angle is 30, we should be able to work out the value of angle X. And to do that is what we can do is, again, remember that the sum of angles is going to be 180. So 180 take away 30 will give us 150 degrees. So the sum of these two angles here is going to be 150. So one angle is going to be 150 divided by 2, which is 75 degrees. So this angle, angle X, is equal to 75 degrees, and this angle will also be equal to 75 degrees. We could also use algebra to solve this problem. And if you're comfortable with forming and solving equations, I think it's really good to actually set up your workings using algebra. So if I just rub all of this out, now what we know is if this angle is X, this angle is also going to be equal to X because they're going to be the same. We're dealing with an isosceles triangle. So what we can say is 30 plus X must be equal to a total of 180 degrees. Remember, angles in a triangle add up to 180 degrees. So what we'll have is 30 plus 2x is equal to 180 degrees. Therefore, 2x is equal to, we need to subtract 30 from both sides. So what we'll get is 150. So 1x is equal to 150 divided by 2, which is equal to 75 degrees. And that will be our answer. I quite like this method because it's mixing algebra with a bit of geometry as well. Right, moving on. So moving on from this, now we go on to polygons. So a polygon is a 3D shape with 3 or more straight sides. So a triangle is a polygon because it has 3 straight sides. Now we have regular and irregular polygons. What's the difference? With regular polygons, and what I have here is a regular hexagon and an irregular hexagon, and we'll get to that in a second. But with a regular polygon, all the length of sides are the same. So we can use these lines to show that the length of sides are the same, and the angles, the interior angles, so these are the interior angles that I'm drawing, will also be the same. So this is what makes a regular polygon. Over here we have an irregular polygon. This is still a hexagon because it's got 1, 2, 3, 4, 5, 6. It's a 6-sided shape, it's a hexagon, but it's not regular, it's an irregular hexagon because not all the length of sides are going to be the same and not all the angles are going to be the same. So a very obvious one is that this angle is not going to be the same as this angle. So what we have here is an irregular hexagon where not all the length of sides and not all the angles are the same, whereas over here we have a regular hexagon where all the length of sides and all the angles are the same. All right, key fact that we need to remember, and that will help us as we progress through the lesson. Now, here's a question. You can pause the video and have a go at this. It says, which of the following are irregular polygons? So we know A is going to be a regular polygon. We just covered this in the previous slide. We know C is going to be a regular polygon because all the length of sides are going to be the same. Again, this is an equilateral triangle. B, however, all the length of sides are not the same. Therefore, this one is going to be an irregular polygon. Over here, what we have is a parallelogram. And whilst these two sides are the same and these two sides are the same, not all the sides are the same length. So for instance, this side might be 6 centimeters and this side might be 6 centimeters. These two vertical sides are going to be, let's say, 4 centimeters each. So this parallelogram is also an irregular polygon. All right, if I just clear this drawings, and we can now move on to finding the sum of interior angles and polygons. So what I mean by the sum of interior angles is that if I was to add this angle and this angle and this angle and this angle and this angle, what would the sum of these interior angles be equal to? Likewise over here, if I was to add this angle, this angle, this angle, this angle, this angle, and this angle. So this is what I mean by interior angles. They're angles on the inside. Now, the first shape we have is a four-sided shape, is a rectangle. Therefore, it is an quadrilateral. So quadrilateral means four-sided. The word quad means four. So quadrilateral means four-sided shape. Likewise, here we have a trapezium. This is a four-sided shape. It is therefore a quadrilateral. Now, we should be able to identify or recognize that these angles over here are all 90 degrees. So the sum of interior angles is going to be 4 lots of 90, so 4 times 90, which is equal to 360 degrees. Now, another way of doing this problem, so for instance, with the trapezium, it's a bit harder because we don't know if these angles are 90 degrees or not, and it's quite clear these two angles are not going to be 90 degrees, and neither are these two. So again, how would we work out the sum of angles in any quadrilateral? Well, what we can do is split the shape up, and this is going back to the first slide where we learned about the angle facts of a triangle. We can split the shape up into 2 triangles, and in fact, I'm going to use a ruler to do this. It will be a lot neater. Here we go. We can create 2 triangles over here. So that's one triangle, and this is another triangle. So that's our red triangle over here. Apologies, it's not perfectly drawn, but hopefully should make sense. So now that we have 2 triangles, we should be able to recognize that the sum of angles in a triangle is going to be 180 degrees, and the sum of angles in this triangle is also going to be 180 degrees. So 2 lots of 180s will give us a total of 360 degrees. So whilst these angles may not be 90 degrees, however, this angle plus this angle plus this angle plus this angle will make 360 degrees. So another key angle fact to remember is that the angles in any, or the sum of angles in any quadrilateral will be equal to 360 degrees. Now we get to this shape over here then. So we have a pentagon, a 5-sided shape. How would we go about doing this problem then? Well, what we need to recognize is that we can split this shape up into, again, I'm just going to rub these out. Here we go. There we go. Right, so I can split the shape up into a triangle, and I also created a quadrilateral, a 4-sided shape. So knowing my angle fact, I should be able to recognize that the sum of angles in this triangle that I've created is going to be 180 degrees, and the sum of angles in this quadrilateral that I've created is going to be 360 degrees. So the sum of angles in a pentagon is going to be 540 degrees. Now, another way of doing this problem, and this is perfectly fine, you can just create one triangle and a quadrilateral and you're good to go. But I want to show you something else, and this will make sense shortly. I can also split this shape up into, whoops, it's not what I wanted. I can also split this shape up into 3 triangles. So this triangle is going to have a total sum of 180 degrees. This triangle, the sum of angles is going to be 180, and likewise over here. Now what we'll get is 3 lots of 180 degrees, which will again give us 540 degrees. Likewise, in the case of this hexagon, to find the sum of interior angles, what I can do is break the shape up, and this bit is quite straightforward, into 2 quadrilaterals. So I have one 4-sided shape on the top and one 4-sided shape on the bottom. So the sum of angles is going to be 2 lots of 360 degrees, but that's going to give me 720 degrees. Alternatively, and this is a longer way, but again, it's required for the next steps. Alternatively, I can break the shape up into 1 triangle, 2 triangles, and 1, 2, 3, 4. So I've created 4 triangles, so I can say I have 4 lots of 180s, which will give me 720. So that's 180, 180, 180, and 180, which will give us 720. Now over here we have a heptagon. A heptagon is a 7-sided shape. Now again, I can go about by splitting up into maybe 1 triangle and 2 quadrilaterals, but I'm just going to split this up into as many triangles as I can. So what we have is 1, 2, 3, 4, 5 triangles. Now again, if we do 5 times 180, that's going to give us 900 degrees. So what do we recognize here? So what do we realize? What is the relationship between the number of triangles that we create and the number of sides each polygon has? So in the case of this shape here, in the case of the rectangle, if I just split the rectangle into triangles as well, so I'm just going to rub this out. So what I can do is split this up into 2 triangles, I should say. What we have is a 4-sided shape, but we've created 2 lots of triangles, which will give us 360 degrees. So what we should be able to recognize is that the relationship between the number of sides and the number of triangles that we create is the difference of 2. So if we have 4 sides, in this case, and I'm just going to use a blue color, if we have 4 sides, we create 2 triangles. If we have 5 sides, we create 3 triangles. If we have 6 sides, we create 4 triangles. And if we have 7 sides, we create 1, 2, 3, 4, 5 triangles. So 7 sides gives us 5 triangles. So to think of a general formula of how to calculate the sum of interior angles, well, if we can calculate the number of triangles we have and multiply that by 180, that will give us the sum of interior angles. So what we need to do is the number of sides, so n being the number of sides, minus 2, because that gives us the number of triangles we want. So 4 minus 2 gives us 2 triangles, 5 minus 2 gives us 3 triangles, 6 minus 2 gives us 4 triangles, 7 minus 2 gives us 5 triangles. So it's going to be the number of sides minus 2 multiplied by 180 gives us the sum of interior angles. And this is a good formula to remember. However, if you do forget the formula, you can always break the shapes up as I have done in this question. So this formula will be useful when you've been given a really, really large shape. They might give you, I don't know, they might tell you work out the sum of interior angles of a 20-sided shape. Now, in an exam, you won't be able to draw 20 sides and then break the shape up. So you will need to remember this formula. However, if you had the shape such as a hexagon or a heptagon or even an octagon, you should be able to break the shape up into a number of triangles, or even triangles and quadrilaterals. It doesn't matter, whichever way you're comfortable with. But it is useful to understand and remember this formula so that you can apply it to shapes that have, lots and lots of sides. All right, now if I just clear this up, so if I clear all the drawings, one thing that I want you to be able to find is each individual angle. Now let's say this is a regular pentagon, and what we just found out is that the sum of angles is going to be 540 degrees. Therefore, this angle plus this angle plus this angle plus this angle plus this angle will give us 540. Now, if you were to work out one angle, what would you do? Well, we've got 5 angles, so this is going to be 540 divided by 5, which is going to be 108 degrees. So each angle is going to be equal to 108 degrees. Now, likewise here, what we have is a 6-sided shape, and we said the sum of angles in a hexagon is going to be 720 degrees. So one angle, because it's a regular hexagon, so we're going by the assumption that this is a regular hexagon, we would have to do 720 divided by 6, which will give us 120 degrees. So again, each individual angle is going to be 120 degrees. And we could apply that to this case with the heptagon as well. So you need to be able to find the sum of angles, and you need to be able to find each individual angle as well. And we can use this method when we have regular polygons. All right. Now let's do some questions then. So what we have here is a kite, and it says find angle ADE. Now ADE, so that's A over here, D over here, E over here. So we need to find the angle of the letter in the middle. So we want this angle over here. So A, D to E. This angle over here, and sorry if I've drawn it a little bit wonky. So what we know is that this angle over here is going to be 90 degrees because we have a perpendicular line. So line AC and line DB are perpendicular, so the angle that's created over here is going to be 90 degrees. Now, using the angle facts that we know, the sum of the interior angles of a triangle is equal to 180. Therefore, 35 plus 90 plus this angle over here should give us 180. So what we can say is, let's call this angle X. 35 plus 90 plus X will be equal to 180 degrees. Therefore, 35 plus 90 is 125 plus X is equal to 180. X is therefore equal to 180. Just clear that up. 180 degrees. And maybe I should put degrees here as we're dealing with degrees, minus 125 degrees. So X is equal to 55 degrees. So angle ADE, even though I've labeled it as X, you could have labeled it as anything. Just use X to stick with traditional mathematical convention, but angle ADE is therefore equal to 55 degrees. All right, now let's find angle DCE. So I'm just going to rub all of this out. Again, if you want to make notes, you can pause the video. But if I just rub all of this out and use maybe a different color pen, I'll use, whoops, right, my apologies, I need to share my screen with you again. There we go. All right, here we go. So now we need to find, so we said angle ADE is 55 degrees. Now we need to find DCE. So we want DCE. So what we want is D to C to E. So the angle that we're looking for is this one here, the middle angle. The angle that's in between D and E, which is angle C. Now we should be able to recognize is that this angle here, so the whole thing has been split in half by this line. So, and we can call this a perpendicular bisector. So we've split the angle in half. Therefore, if this angle is 25, this angle is also going to be 25. So DCE is equal to 25 degrees, and that's pretty straightforward. Now, let's find ABC. So we want A, B to C. So now it's slightly different. So we want, and if I just draw it using lines, we want A to B to C. So we want this whole angle over here. So the whole angle, and I've drawn it a bit wonky, so maybe I can just draw it again. So we want the whole angle over here. Now, what we have is, again, if I draw another line, we should be able to recognize that we have a blue triangle over here. So we know this angle is 25. This angle over here, again, we can apply what we did down here. We should be able to recognize that if this angle is 35, this angle is also going to be 35 because it's been split in half. The whole angle has been split in half by this perpendicular bisector, by this blue line over here. So now what we have is a triangle which has one angle which is 35 degrees, another angle is 25 degrees, and this angle is therefore going to be, well, we can use what we know about our triangle facts. So 35 degrees plus 25 degrees plus this blue angle here, which I'll call X, it's going to be equal to 180 degrees. So this will give us 60 degrees plus X is equal to 180 degrees. X is therefore equal to 180, take away 60. X is therefore going to be 120 degrees. Now, is this correct? Well, just a fact about kites, these two angles over here, so angle B and D are actually going to be the same. So what I want to check is, do the angles, if this angle is 120, would the sum of the angles add up to 360? Because remember, in any quadrilateral, the sum of angles would be 360. So let's try this out. These two angles together, so I'm just going to shade in all the angles to know what angles we're trying to work out. So these two angles together give us 70. So we'll have 70 plus these two angles, which will give us 50, plus 120, plus 120. What we'll get is 70 plus 50 is 120, plus another 120 is 240, plus another 120 is 360 degrees. So this angle that I've worked out is correct because it fits in with the angle facts that we know about quadrilaterals. So why I've done this is just to check that if this angle is 120 and this angle is 120, will the sum of all the angles in the kite add up to 360, which in this case it does. All right, let's do another example. So if I just clear all the drawings, and this is going to be 120. All right, let's move on. I'm just going to skip this question because again, this focuses on triangles, and I think the last example had quite a lot of triangles involved. So I think this example will be a lot better to focus on. So what we have is a six-sided shape. It's a hexagon, but it's not a regular hexagon. It's not a regular hexagon, so it makes life a little bit more tricky. But what the question says is angle CDE, so CDE, again, we want the middle angle, so this angle here is equal to 2 times angle BCD. So angle B is on the top over here, BCD. So we want this angle over here. So CDE is equal to 2 lots of BCD. So if, let's say, just to make sense of this bit here, because this bit can be a bit confusing, if angle CDE is 100 degrees, well, BCD will have to be 50, because 2 lots of 50s will make 100. Likewise, if this angle was, say, I don't know, 200, so if CDE, if this angle was 200, the angle BCD is going to be 2 times 100. So essentially, this angle here is twice as big as this angle over here. And the way to represent this, again, you might have to use a bit of algebra here. The way to represent this could be that if this angle was x, well, this angle over here is twice as big, so this angle is going to be 2x. And once we've managed to figure this bit out, it makes our life a lot easier. Now, what is the sum of interior angles? Because ultimately we need to work out the size of angle CDE. And to be able to do that, we need to understand what is the sum of the interior angles. Well, what we have is a hexagon, so we can create 2 quadrilaterals, or you can split the shape up into as many triangles as you want, but I'm just going to take a shortcut and create 2 quadrilaterals. So the sum of angles is going to be 1 lots of 360 plus another lots of 360, which is 720. So the sum of 129 plus 125 plus 121 plus 144 plus x plus 2x, so we have 3 lots of x's, plus 3x is going to give us 720 degrees. Now we need to solve for x, so I'm just going to use my calculator to speed things up. So 129 plus 125 plus 121 plus 144 is equal to 519 plus 3x is equal to 720 degrees, and better use degrees. What that will give us is 3x is equal to, subtract 519 from both sides, so we should be left with 201 degrees. And then to solve for x, we need to divide both sides by 3. So x degrees is equal to 201 degrees divided by 3 degrees, which will equal to 201 divided by 3 is equal to 67. So x is equal to 67 degrees. Now it says work out the size of angle CDE. CDE we want, so if x is 67 degrees, 2 lots of x is going to be equal to 134. So angle CDE is equal to 134 degrees. And here's our answer. Now, it might seem like we did a lot of work here, but really this is just the algebra that's making life a bit more difficult. Once you're really comfortable with finding the interior angles and you're comfortable with setting up equations, I don't think you will have any problems. Right, boys and girls, I hope you found this useful and have a very nice day.